In this video, we're going to be looking at answering questions about quadratic functions using their graphs. On these examples, you already have the equations and the functions graphed for you. If you needed to see them, Desmos, again, is the fastest and easiest way to access those. So on number one, we're just going to review some of this vocabulary. So they give us the quadratic function. They want us to find the axis of symmetry, the vertex, the intercepts, solutions, domain, and range, and then identify if the vertex is a maximum or a minimum. We're going to start with the vertex. This graph is concave down, which means our vertex is a maximum, so it's a peak or a high point. And we can see from the graph that that is at 214. The axis of symmetry is the imaginary line that runs straight through. So it's that blue line that they have marked there on that graph. So we write that as the equation of a vertical line. On that line, x is always equal to 2. The y-intercept of the graph is the c value of the equation. So it should be at 6. And if we come down here and look at the graph, we see that we have a y-intercept at 0, 6. Solutions are the same thing as x-intercepts. So x-intercepts, roots, solutions, zeros all mean or ask us to find the same physical characteristic on the graph, so where we're crossing the x-axis. So this graph has two solutions. One is at about negative 0.60, and the other is at about 4.60. Domain of any quadratic function is all real numbers. The range, we're going to use the y value, so we want to figure out what y value we're always going to be above or below, which is going to be from the vertex because that's the highest or lowest. So the range of this graph is such that y is always going to be less than or equal to 14. And again, that's the y value from the vertex to figure out where that value is. In example 2, if a current I is flowing through a certain electrical circuit, the power W of the circuit can be determined by the formula W equals 120I minus 12I squared. Using a graphing calculator, determine the amount of current it will take in amperes to supply the maximum amount of power in watts. So our function, W is the output, so the y-axis is representing the power. I is the current, which is measured in amperes. I think that's how you say that. So again, your x-axis is your input. That is the current. We want to maximize. So we look at that as a key word. If they ask us for the maximum, then we're asking for the highest point. So we would find the vertex. So that is your keyword. That means for that scenario, you're finding the vertex. Again, in this scenario, the ordered pair is representing current as the x value, power as the y. So when we have a current of 5, we are getting 300 watts. The question is to determine the amount of current it will take, which means our answer is the x value. So 5 amperes, I think. Again, that's how you say that, would be your answer. If they asked for the maximum amount of power, then we would have given the y as the answer. In example 3, an apple falls from the branch of a tree to the ground 25 feet below. The distance the apple is from the ground as it falls is represented by the equation d of t is equal to negative 16t squared plus 25. When you get to physics, you'll see that type of equation a lot because that is our force of gravity, that negative 16 on Earth. So sketch a graph. So we have the graph from our graphing calculator, and calculate to the nearest hundredth of a second the time the apple will take to reach the ground. So if we're reaching the ground, right, we have to be hitting the ground. So that means we're going to have a height equal to 0 when we hit the ground, which is our x-axis. Okay. Now we're starting here. We actually don't even need the back half of this graph because that would be negative height and negative time, which we can't have negative time. So we're really just looking at the first half of this graph, the front half, the right side with the decreasing interval. So we look at the x-intercept to answer this question. How long is it taking it to get back to the x-axis? This is time in seconds, so it's taking that apple 1.25 seconds to reach the ground once we throw it from, or if it falls from 25 feet in the air. So hitting the ground, returning to Earth, those kinds of questions, we're going to be looking for x-intercepts. In example 4, the path of a rocket fired into the air follows a parabolic path. The formula to determine the height of the rocket in feet can be found by combining 3 terms that represent different forces acting on the rocket. The 3 terms affecting the rocket are identified in the formula. So we have the effect of gravity. You see there you have a t squared, the initial speed, and the original height. So they're actually giving you your equation that we're going to be working with. The rocket is launched from the ground with an initial velocity of 128 feet per second. If the effect of gravity on any object on Earth is approximately negative 32 feet per second squared, write an equation that represents the height of the rocket as a function of time and answering the following questions. So again, we are simply looking for the places that we can replace these with the information in the scenario. We have the initial velocity of 128 feet per second, and we have the effect of gravity at negative 32 feet per second squared. So we're plugging in the numbers 128 and negative 32 into these 2 places that I have highlighted. So h of t is equal to 1/2. The effect of gravity is negative 32. Don't forget you have a t squared. That's where our quadratic, our parabolic shape comes in. Plus the initial speed of the rocket is 128 feet per second. That's being multiplied by t. And our original height is at 0 because we're launching from the ground. So you can also see that here on the picture, but they don't tell us that we're launching anywhere off of the ground, so we're going to assume that it's 0. So that's our equation that we're going to use to answer the question, what is the height of the rocket after 2 seconds? Well, this is time, so we're going to plug that into t. I didn't leave myself enough room, so we're going to go up here. So h of 2, that means I'm plugging that number in place of t. Actually, I'm going to go ahead and change this. 1/2 of negative 32 is negative 16. And then every place I have a t, I'm replacing it with the 2 because that's what the function notation is telling me to do. And again, I don't have to add the 0. And I have my calculator. So 2 squared is 4. 16 times 4 is 64. There's a negative there, so that's negative 64. And then 128 plus or times 2 should be 256, but I'm going to check it just to make sure. So 256. When I add 256 and negative 64, my height at 2 seconds is 192 feet in the air. How long will it take the rocket to reach its maximum height? So again, we see the word maximum. That means we're looking for a vertex. That's our key word there. So on the graph, we see that our vertex is at 4 to 56. Remember, the first number is time, and so that's how long will it take. So at 4 seconds, the rocket is going to be 256 feet in the air. That is the corresponding Y value. Part C, when will the rocket reach 100 feet? So we're looking at 100 on the y-axis. So we're looking at where those two things would be intersecting. You could actually graph the line y equals 100 in Desmos and then find your two actual intersection points. I'm just going to estimate here that it's about 1 second and a little bit more than 7 seconds. So we have 2 points of intersection that we would be using. And again, if you're on Desmos, it's going to give you a precise number. I'm just estimating from the graph that I have. What is a realistic domain for this function? So realistic means what numbers can I actually use if I'm talking about time and height? We only use positive numbers for time and height. So I would only be in the first quadrant. And the two places where I would move or leave the first quadrant would be at the x-intercepts. So I can only look at the graph that is in between 0 and 8 to give me the height. Because anything else, if I move into the negative numbers, is going to be negative time and negative height, which does not make sense in the context of this scenario.